does contouring have to do with calculus? Welcome to Curly Calculus. Please subscribe and stay tuned. If you've gotten to contour map levels of calculus, congratulations on getting past Calc 1 and 2. But if you haven't yet, keep pressing on, you'll get there. Don't quit before the first exam. Keep on going. The main marker of Calc 3 is going through a different whirlwind of topics that don't look related to Calc 1 and 2. Calc 1 or derivative calculus is like taking a line and making it less descriptive as you keep taking the process. Calc 2 or integral calculus is taking that line and finding that space underneath it. Now imagine taking that 2D shape and then flipping it up and then finding the volume underneath that. That's Calc 3 after you go through like high levels of pattern recognition. That's sequences and series. The actual term is finding the volume underneath the surface, just as in Calc 2, you are finding the area underneath the curve. See how volume is one dimension greater than a surface or a 2D shape, and then finding the area underneath the curve? Well, that's 2D and a curve is just 1D. But back to 3D. Contour maps is a topic that you will cover in Calc 3. And you've actually seen contour maps before in elevation maps. Now on my face, I have contours marked out to show where I want things to appear deeper or further away than where they actually are. And when you're looking at an elevation map, each circle shows that you're going up higher on a mountain. In my opinion, contour maps in Calc 3 are a little more general than this kind of contour or an elevation map. This is something you might see in Calc 3. And in this case, the smallest circles aren't at the same depth. One is at the highest height and this one is at the deepest depth, whereas the largest circles are closest in depth, rather closest to each other. From a different viewpoint, so instead of looking up here, we're looking at the side, this is what it would also look like. See where we've got two narrow points, one at a very deep depth and one at a very tall height, and then where it's widest, it's closest together or closest to each other. This may aid in the visualization. Contour maps aren't that difficult. I know that at least for me, we didn't spend that much time on it. We spent way more time on vectors, but that's contour for you. If you like that video, please give me that thumbs up and I will see you next time. Bye.